Good evening, everyone. I am Yashwardhan Singh from MIT Academy of Engineering, and I am here to explain a very good example of digital image processing, how extraction of images are done through morphological features. Moving towards the contents, the presentation totally contains introduction of a DIP, its application in various fields, different operations in MATLAB, which are required in morphological features. What is morphology? What are different types of morphological operations, and MATLAB simulation on on that morphological operations. Moving towards the introduction. Now, introduction. First of all, we should know about what is a digital image. Digital image is nothing but it is a representation of 2D image, that is x coordinate as well as y coordinate, as a finite set of digital values called picture element or pixels. Pixels are value typically represents the gray levels, colors and height, etc. Now, what is DIP? DIP is an acronym for digital image processing, and it generally focuses on two major tasks. First of all, improvement of pictorial information for human interpretation, through which general information can be interpreted, processing of image data for storage, transmission, and representation of autonomous machine perception. And one of the most common use of DIP technique is improving the quality, removing the noise. For example, just let us take an application in field of medicines. How digital image processing helps in implementing through different images and gaining out information, required information. We have taken a slice form of MRI scan of a canine heart and find the boundaries between the types of issues. First of all, image with a gray level represents tissue density. Use of suitable filter to highlight the edges. These implementations are done through a MATLAB code in which suitable filter is used to highlight the edges and to show the boundaries which represents the tissue density. Here we can see an image of a dog's heart, original MRI image, and after implementing through some operations, we just obtained the edge detected. We just detected the edge of the image. Now, what are the different applications of digital image processing? Digital image processing is not just limited to adjust the spatial resolution of the everyday image captured by the camera. It is not limited to increase the brightness of the photo, etc. Rather than it is far more than that. Our human eye can only see the visible portion in which we saw all the objects, but a camera can see the other things that a naked eye is unable to see and extract the information, which is not possible through a naked eye. Some of the major fields in which digital image processing is widely used are mentioned below. These are image sharpening and restoration, medical field, remote sensing. These are generally used through satellites, transmission and encoding, which are generally used in communication process, color processing, which is very important type of processing used in forensic labs, pattern recognition, which are generally inbuilt in mobile phones and laptops and may be used for security purposes, video processing. These are very required for telecommunication of different videos. The moving towards the main part of the discussion is morphology. Binary image generally consists of pixels that can have one of exactly two colors, usually black and white, that may contain numerous imperfections. Noises and textures can be distorted when binary regions produced by simple threshold. So here morphological operations in image processing pursues the goal of removing these type of imperfections by accounting for the form and structure of the image. With the help of with the help of these structures of image, these morphological operations are carried out in various ways. Now let us understand what exactly is a morphological operation. A collection of non-linear operation related to the shape or morphology of features in an image is actually known as morphological operations in image processing. Morphological operations rely only on the relative ordering of pixels value, not on their numerical value. Hence, these techniques can also be extended to grayscale images such that their light transfer function are unknown and therefore their absolute pixel values are of no or minor interest. Now let us understand about structuring element, because with the help of a structuring element only the morphological operations are being carried out. A small shape or a template called a structuring element, it is a matrix that identifies the pixel in the image being processed and defines the neighborhood uses in the process of each pixel. Actually, it's a mathematical process and it is used to probe an image in these morphological techniques. Generally, this type of morphological techniques, the neighborhoods of the neighborhood corners of the images are being captured. The list of operations are dilation. It is generally represented by plus symbol. Erosion, generally represented by minus. Opening, that is plus come minus, and then closing, just opposite of opening, that is plus come minus. And gradient is nothing but finding out the slope of the image. Now let us discuss about the first operation, that is dilation. Dilation is a morphological processing of growing an object in binary image. It is generally shown by plus image. Here we can see a code of dilation, and just behind this image we can see a dilated version of A, which is broadened in shape. It is generally a 3x3 matrix, and the original image is a binary image. Here is inbuilt function in MATLAB is done, that is strel and im dilate. Image dilate is the inbuilt function which helps in dilation. In a very similar order, erosion, the next morphological operation, is carried out on the MATLAB. Erosion is another morphological operator in binary image for eroding the pixels of objects in the image. It is generally shown by minus symbol. The inbuilt function in MATLAB for erosion is image erode, in which we can pass a binary value of the binary image and the SE, that is the square image. Now moving towards the last section of this presentation is the extraction of morphological features. It's a detailed application which I am going to discuss through various steps. The first step involves the original and the background image read. We will read the image. Suppose this is the image which has to be read. Now moving towards the next slide. In step 2, cropped original image is subtracted from the background image, and cropping process is used for extracting the specific area from original image. And in the step 3, we will see a subtracted image, which is this, and which converts a gray image as shown in the figure 5, which is this. Moving towards the next step is thresholding process is applied to the gray image of the for converting the binary image. We can see here the image. The actual MATLAB operation will be discussed in further slides, so keep patience. Next step involves labeling, and before labeling, connecting pixels which groups which are similar than a specific value are removed. We can see this thing in this image. The same the MATLAB code will be discussed later in the next slides. And at last, after labeling, we can find all objects morphological features as shown in figure 9, which is this is the final figure, the written codes in the image. Here is the MATLAB code for the same. First operation is carried out, that read image, and then reading the background image. Then this operation is done for cropping the image. Now subsequently the subtracting is done through IMSubtract function, and the next conversion of RGB image to a gray image is done through a MATLAB function of RGB to gray. And finally, a threshold value of gray image is acquired, and then applying that threshold value to the gray image for converting the binary image. Here in the moving towards the next part of the code, labeling of image are done through different colors. Labeling of code are done through different colors. And then plotting the we are running a loop from 1 to length of the image for plotting the boundary of an object as discussed earlier. Then finding the morphological values, that is area, centroid, maximum intensity, minimum intensity is required. For that different formulas has been passed. For example, for parameter, the sum of square of the sides, and for area 4 pi area upon perimeter by 2. And moving towards the next slide, here the area of the minimum bounding box is find. Then mean, max, and minimum intensity of the values has been called. And in the very similar way, each and every things are displayed by writing the calculating morphological values of the image. And through this, the total code has been done. It is explained over here. Thank you so much for attending this, for seeing this video. I hope I made my all points clear. Thank you so much to everyone.